In this goal, we will be talking about ionic and covalent substances and looking at their characteristics. We are going to review ionic and covalent bonding, so a little bit of it you will have learned from previous classes, but then they'll have some new information. In ionic bonding, electrons are transferred. The nonmetal is very electronegative. The metal has a low electronegativity, and so as a result, the nonmetal ends up taking the electron from the metal. What results is an anion or a negative ion, and the metal becomes a cation, and so you end up with this repeating arrangement of positive and negative. So it doesn't just happen once, but it will happen hundreds, thousands of times, and it will make an ionic crystal. You also can mathematically figure out the electronegativity difference, and the dividing point for whether it's ionic or covalent is if it's 1.7 exactly or larger, then we call it ionic. If it is less than that, then we call it covalent. And remember, you can look up those electronegativity numbers on the back of your periodic table in the upper right hand corner of each of the elements. So here's some new information. So ionic substances, they are all solids and they are called salts. And we are very familiar with table salt, so NaCl. And we call that a salt, but there are other salts. You can go to the grocery store and buy a salt substitute, and when you taste it, it does taste salty. And its formula is KCl. And the reason why people consume that salt is because they're trying to cut down on the amount of sodium in their diet, and so KCl will not interfere with their sodium levels. So when we look at something that's ionically bonded, we have cations and we have anions, and again, the nonmetals gain the electrons and so they become the anions. Ionic salts, they have very high melting points, and this is because the bond is so strong. So in order to break that bond, you would have to put in a lot of heat or a lot of energy to break that. And so normally in the laboratory, we would not be able to melt an ionic salt just because it has such a high melting point. So well-defined crystals, like I've already mentioned, and this is interesting. The ionic salts, they're hard, but they're very brittle. And this has to do with their lattice arrangement of positive, negative in this repeating pattern. Now, notice in the crystal lattice that you do not have the cations touching other cations and the anions don't touch other anions. So they keep separated by the other ion. So if you already use some sort of force and shift the crystal lattice over, you can see that the positive might shift over to be by another positive. And if that is the case, remember that like charges repel. And so it would shift over and then repel apart. And we described the salt crystal as being brittle. Ionic substances, they do not carry a current as a solid, but you can melt the solid down by putting a lot of heat into it, and then it will conduct. Also, you can take the ionic solid, and a lot of them dissolve very well in water. And I have a picture of that here at the bottom of the slide. So when it dissolves in the water, the anions, they break free from each other, and they are now surrounded by the water molecules. And because you have something that is free to move, then it will conduct a current. It does this when it's molten also. So if I had a positive charge over here and a negative charge over here, you would see the ions travel to the opposite side. So you would see your negative ions go this way, and you would see your positive ions go this way. And because the ions are moving and they can carry a current, they are called electrolytes, and they will keep flowing to each of the opposite charged electrodes and carry that current. A lot of times, if we're exercising hard, we might drink a drink that has electrolytes in it, and that is to replace the salt that we sweat out. And these electrolytes is just a fancy name for ionic salts that have been dissolved in. So it might not just be sodium chloride, but it might be other salts that have maybe calcium in it or magnesium in it to replace, again, the salt that we sweat out. Let's now go to covalent bonding. So remember, in covalent bonding, we are sharing electrons. Typically, it is the bond between nonmetal and a nonmetal, and because they're pulling equally or about equally, they will end up sharing those electrons in the bond. And you don't have to have just two atoms involved. Down here, there's a picture. This is methane gas, so CH4. This is the gas that we burn in the lab, and you can see that the carbon is bonded to four hydrogens, and those are covalent bonds, and it will share those electrons in the bond. Covalent substances are called molecules. So notice it looks very different. So here we have a molecule. It's like an isolated thing, so it's not attached to another methane molecule. Unlike your ionic salts, remember, have that repeating pattern of positive, negative over and over again until it can have like thousands of ions. So molecules, they tend to be very small, and they can have attractive forces between them, something that we will talk about in our next unit, but we see that they're all separate little entities. Characteristics of covalently bonded substances: we see that they are solid, liquid, or gas at room temperature. Down here at the picture, there's a picture here that I have a solid. This is a waxy candle. This liquid right here is bromine. And right here, this is the gas oxygen. So at room temperature, covalent substances can be in any phase. The solids can be soft and waxy like this candle, or plastics are covalently bonded. And some plastics are quite soft and some are quite hard, but they are covalently bonded. Covalently bonded substances will not conduct electricity in any phase, and this is because there are no electrons or charged particles that can move around to carry the current. So because we have these isolated molecules, there's nothing that really can be broken off or that is a charged particle that can be moved around. Because they don't carry a current, they are good insulators. So often you'll see metal wire wrapped in plastic, and that is to insulate against if there was a current going through that metal. So it's to avoid the person working with the wire becoming shocked. Covalent substances do have low melting points and lower boiling points. In fact, oxygen right here that we already talked about, it has already boiled. So by the time we get to room temperature, it already passed through the temperature where it melts and then the temperature where it boils. So it's a gas at room temperature.